Hey, my name is Maverick091, and today I will be talking about electrical current. Before we can talk about current, we have to understand what a circuit is. Now, many of you probably have used some type of device where circuitry was in it. Maybe a calculator, maybe your cell phone, maybe a computer even. They all have one thing in common. They all use electrical circuits. Now, what is a circuit then? A circuit is an interconnection of electrical components where each of those electrical components has a mathematical model describing their functionality. Now, what does this mean? Well, it pretty much means that there are electrical components and they are interconnected through conductive materials. The most commonly used electrical materials are copper wires. Now, before we can talk about what current is, we have to understand how electrons move, because once we understand that, then it's really obvious how current works. Because current is essentially the motion of electrons. Say we have two plates, this being a negatively charged plate, this being a positively charged plate. From physics, we probably know that the electric field moves from negative to positive. And this is the E field. So if there is a free electron between the two plates and inside the electric field, which way is it moving? Well, we know that common charges repel each other. Since this is a negative charge and this is a negative plate, the charge will be repelled from the plate. And similarly, since this is positive and this is negative, they will attract, meaning that the electron will move from the negative plate to the positive plate, and in the same direction of the electric field. Now, if we have an unknown circuit where all we know is that the polarity of the two ends is positive and negative, we know that the electrons in this conductive wire here will cause the electrons in the wire to flow from negative to positive. So that's what current is. Current is the flow of electrons, and we talk about current mathematically as the time rate of change of the charge, meaning that how much charge is flowing through the wire at any given moment in time, and it is measured in amperes, which means 1 coulomb per 1 second. So if this circuit right here had 2 amps flowing through, so there would be 2 coulombs of charge flowing through the wire every second. Okay, so now we'll talk about conventional flow and what that is. Let me clear some room first. So what is conventional flow? Conventional flow. Well, hundreds of years ago, scientists didn't know which way, or didn't know what moved in an electric field. And what they ended up assuming was that the electric field actually moves from positive to negative, which was just an assumption. They had no evidence and no proof. They just assumed that it worked this way. We find out now that they're actually wrong, and it's actually moving from the negative to positive. But back before they knew what was moving, they assumed that the protons were moving instead of electrons moving this way. So pretty much all of the formulas that describe electrical components and circuitry use this assumption that the protons are actually flowing instead of electrons. So we generally label positive current flowing from positive to negative. So say if this was 2 amps right here, we we can also write this current as negative 2 amps. Even though we know that the current is actually from the negative to positive, it's useful to just think of it as it actually flowing from positive to negative. And these are the same circuits. Okay, so we generally don't know what the polarity of the terminals would be. Positive, negative, negative, positive. We generally don't know. So say if we had a circuit right here, and we didn't know anything about it. Okay, so we didn't know what the polarities were. We didn't know anything. If we were to solve for whatever is in the circuit, and we can just assume a current direction. So we just call this I. And when we do the calculations, if the current is flowing in our assumed direction, it will show up as a positive. So this is right. Our assumption is right. If it's a negative, our assumption is wrong, and the current is actually flowing in the opposite direction. And if you have any questions, please let me know. We'll go into more detail about how to solve for current and how to find if it's positive or negative, and if our assumption is right or wrong in later videos. Another thing you should know about current is that there are two types. There's direct current, and then there's alternating current. Now, direct current looks something like this. It has I and T here, and essentially it has a constant value. Now, where this behavior is typically seen are in batteries, and anything that runs off batteries has direct current run through it. Say a flashlight, or a calculator has direct current. Torque. Alternating current, however, looks something like this. It has a lot of forms, but typically they're all periodic. And the most common is the sinusoid, with a value of A here and say negative A here. And where this behavior is most commonly seen are in the wall sockets in your house. So wall sockets. And anything that's plugged into the wall socket, such as a computer or a hairdryer, has alternating current flowing through it. And what else you can think of too. There are hundreds of applications, probably thousands, probably even more than that has alternating current. It's probably the most important form of current. And yeah, that's all you really need to know of a current.